Welcome to Singularity Vault. Our channel is your one-stop destination for all things science and technology. Make sure to subscribe and hit the bell for regular updates. Have you ever wondered where our future energy might come from? Could the answer be in space? Let's take a tantalizing journey into the realm of space-based solar power. Imagine colossal solar collector arrays, gracefully orbiting Earth, soaking up the sun's unfiltered, ceaseless energy. They're not just basking in the rays though, they're hard at work, converting sunlight into electricity and then beaming it back to us on Earth. This futuristic concept isn't just a dream, it's a groundbreaking technology that could revolutionize our energy landscape. It's called Orbital Solar Collectors and energy beaming, and it has the potential to play a transformative role in meeting our ever-growing global energy demands. Here's how it works. Solar collectors in space, unhindered by atmospheric interference or the day-night cycle, can capture solar power 24/7. They convert this power into electricity, which is then transformed into microwaves. These microwaves are beamed down to Earth, caught by ground stations, and converted back into electricity. This electricity can then be fed into our power grids, lighting up homes and powering industries across the globe. But what makes space-based solar power so promising? Well, the sun's energy is clean, renewable, and virtually inexhaustible. Harnessing it directly from space, where it's always available and at a constant intensity, could give us a virtually limitless supply of power. It could help us meet our energy needs without contributing to climate change or depleting finite resources. Of course, the journey to realizing this vision is not without its challenges. There are engineering intricacies to solve, safety concerns to address, and economic feasibility to consider. But with the rapid advancements in space technology and the decreasing cost of reaching low Earth orbit, the prospect of space-based solar power is becoming increasingly viable. If we can harness the power of the sun from space, we may have found the key to a sustainable energy future. And that, my friends, is a future worth striving for. So let's buckle up and take this exciting journey together as we dive deeper into the marvels of space-based solar power in this video. Orbital solar collectors are not just a concept, they are an engineering marvel. Here's why. Imagine a colossal structure or huge constellation of satellites floating in the vast expanse of space, perpetually bathed in sunlight, harnessing this infinite energy resource. This is the reality of orbital solar collectors. These high-tech structures are designed to capture solar energy directly from the sun without any atmospheric or weather-related interruptions, unlike their terrestrial counterparts. The engineering behind these collectors is a marvel in itself, a testament to human ingenuity and ambition. They are composed of large arrays of photovoltaic cells or solar panels, arranged in a manner that maximizes exposure to the sun. These arrays are often paired with concentrators that focus sunlight onto the cells, significantly boosting their power generation capabilities. But capturing solar energy is only half the battle. The real challenge lies in transferring this energy back to Earth. To tackle this, orbital solar collectors employ a technique called energy beaming. This process involves converting the collected solar energy into microwaves, a form of electromagnetic radiation that can travel through the vacuum of space and the Earth's atmosphere without significant loss. These microwaves are then directed towards ground stations on Earth, where they are converted back into electricity and fed into the power grid. This transmission is carefully controlled to ensure it is directed precisely at the receiving stations, minimizing energy waste and ensuring safety. And so, through a symphony of complex processes and precise operations, these orbital solar collectors transform the raw, unfiltered energy of the sun into usable power for our homes, businesses, and cities. They give a new meaning to the phrase, power from above. But perhaps the most exciting aspect of orbital solar collectors is not just their current capabilities, but their potential. As our technology advances, these collectors could become more efficient, more powerful, and more integral to our global energy infrastructure. Orbital solar collectors give us a glimpse into the future, a future powered by the sun, from space. The idea of space-based solar power is not new. It has been around since the 1940s, thanks to science fiction author Isaac Asimov. Asimov's work often delved into the realms of the future, painting vivid pictures of what technology could become. One such idea was presented in his short story Reason, where he explored the concept of collecting solar energy in space and beaming it down to Earth and to other planets. In Reason, Asimov introduced us to a space station run by robots, tirelessly capturing the unfiltered power of the sun and sending it back to Earth in the form of microwave beams. This was a time when space travel was still in its infancy, let alone the idea of harnessing solar power from orbit. Yet, Asimov's story left a lasting impression, planting a seed that would eventually grow into a field of study and exploration. Fast forward to the 21st century. Asimov's science fiction is now on the cusp of becoming science fact. Engineers and scientists across the world are working to turn Asimov's vision into a reality, taking advantage of the sun's ceaseless energy and the vast expanse of space. The journey from idea to reality has been a long one, filled with countless hours of research, design, and experimentation. But the dream of harvesting the sun's energy from space is now closer than ever. Developments in solar panel technology, advances in microwave transmission, and the ever-decreasing cost of launching payloads into space have all contributed to making space-based solar power a viable concept. As we stand on the threshold of a new era in energy production, we can't help but look back at Asimov's story. His vision of a future powered by space-based solar energy was bold and imaginative, but more importantly, it was prescient. It foresaw a time when humanity would look beyond the confines of our planet for energy solutions. Asimov may have imagined it first, but today, his vision is becoming a reality. The seeds planted by his story have grown into a tree of knowledge and innovation, and we are now beginning to reap its fruits. As we continue to explore the possibilities of space-based solar power, we honor the legacy of Isaac Asimov, a true visionary of his time. The journey from concept to reality has seen significant milestones. Let's dive into them. In the world of orbital solar collectors, one of the key breakthroughs was the Microwave Array for Power Transfer Low Orbit Experiment, or MAPLE for short. This was a revolutionary project from Caltech that tested the feasibility of energy beaming from space. The experiment was carried out on the SSPD-1 Satellite, a beacon of technological advancement, in 2023. MAPLE's successful operation demonstrated that it was indeed possible to collect solar energy in space and beam it back to Earth. This was achieved through the use of microwave energy, a form of electromagnetic radiation that can travel through the vacuum of space unimpeded. The success of MAPLE marked a new era in the exploration of space-based solar power, bringing us one step closer to realizing the dream of unlimited renewable energy. But the journey didn't stop there. China, a nation known for its ambitious technological pursuits, has set its sights on space-based solar power as well. The country has outlined a grand vision for a space-based solar power station, or SBSP. This isn't just a small-scale experiment, but a fully fledged space station designed to harvest and transfer megawatts of energy back to Earth. The plan is audacious, to say the least. By 2035, China aims to have this colossal power station in operation, harnessing the sun's energy 24/7 and beaming it back to Earth, rain or shine. This would be a game changer for renewable energy, providing a constant and virtually limitless source of power. These milestones represent the significant strides we've made in transforming the concept of space-based solar power from a science fiction dream to a tangible reality. The successful operation of MAPLE, the ambitious plans for China's SBSP, and the continued advancements in this field are all testaments to human ingenuity and our relentless pursuit of sustainable energy solutions. The future of energy is not just a dream, it's a plan in motion. While the prospects are exciting, let's not forget to examine the viability, safety, and potential benefits and drawbacks of this revolutionary energy solution. The future of space-based solar power hinges on several factors. First, the falling cost of access to low Earth orbit is a key driver. As costs continue to tumble, the economic viability of space-based solar power strengthens, in large, thanks to private launch providers like SpaceX and Rocket Lab. Second, safety is paramount. While energy beaming may sound like something out of a science fiction movie, the technology must be robust enough to ensure that these supercharged beams of energy are delivered precisely to their intended ground stations. The potential benefits are staggering. Imagine a world where energy is clean, abundant, and available around the clock, regardless of weather or geographical location. However, the challenges are equally significant. Technological advancements are needed to ensure efficient energy capture, storage, and transmission. The future of energy is as exciting as it is challenging. As we stand at the dawn of a new era in energy production, it's important to consider both the potential and the challenges of space-based energy beaming. This technology, harnessing the unfiltered power of the sun from space and beaming it back to Earth, could revolutionize our energy landscape. It promises near-limitless clean energy, potentially solving the global energy crisis and significantly reducing our carbon footprint. It's a tantalizing prospect. Yet, there are hurdles to overcome. The cost of launching and maintaining orbital solar collectors is staggering. And then, there's the question of safety. How do we ensure that energy beams don't cause harm when they reach the Earth? We also need to consider the geopolitical implications of having energy sources in space. How would you feel if a rival country had powerful microwave beam satellites floating above you that could target any place on Earth? Can they be made harmless? These challenges, while significant, are not insurmountable. The potential benefits of space-based energy beaming are too great to ignore. So, could the future of energy really be written in the stars? Only time will tell. Feel free to discuss this further in the comments below this video, and don't forget to subscribe for more space and technology updates. Until then, keep looking up.